Project Beamformers engaged.
Hello everyone, my name is Shashank. This is my submission for the VisualSim Electronics Hackathon challenge. Today I will compare ARM7 and ARM8 processor running AES-capable encryption using VisualSim simulation. AES Advanced Encryption Standard is the most widely used encryption algorithm in the world. It predicts your banking transactions, your messages and your IoT devices. AES-256 is the strongest version used by government and defense systems. The question is, which processor, ARM7 or ARM8, handles the AES best on the embedded hardware? Here is the AES dual platform in the VisualSim. Simulation time is around 600 microseconds and clock speed is around 50 megahertz. Okay, so AES key size is of 256 bit. So over here it is around 4, that means it is 256 bit. So the hardware has 2 ARM core connected through a bus, 2 L2 latch and SDRAM. The software reads AES tasks data from an annotation file and sends it both cores. I ran the exact same model for the both ARM7 and ARM8 with the same settings for the fair comparison. So here is the result for the 600 microsecond. First, processor utilization. So let me take you to the processor utilization. These are already run simulations. Let's start. Both are running at same 50 megahertz. Time is same. Time is 600 microseconds. And let's start with the utilization time. Processor utilization. So processor utilization for the ARM7 is around 21%, whereas ARM8 is around 20%. So this is almost same, nearly identical. Both processors are handling same amount of work. This is where everything changes. So bus utilization, where everything changes. So ARM7, let's see ARM7 bus utilization is around 11.2%, and similarly for the bus utilization for the bus utilization mean which we have to check. So it is around 95%, whereas bus utilization mean for the ARM7 is around 9.8%. This is 10 times difference on the same clock speed. So ARM8 is almost completely saturating its bus. So if workload increases, so similarly workload increases, ARM8 hits a wall. So it's not so it's going to consume more power when compared to ARM7. So bus utilization, based on the bus utilization, so let's discuss about the average power. On the left hand side ARM7 and on the right hand side it's ARM8. So we can see the graphs and tell that ARM7 is consuming significantly less power compared to the ARM8. So for the IoT devices running on battery, this difference matters a lot. So what does this mean in the real world? ARM Cortex M4 runs at 200 megahertz in the real products. Even at 200 megahertz, ARM7 bus still has a penalty of headroom, whereas ARM8 Cortex A53 runs at 1.4 gigahertz, 28 times our test speed. At that speed, the bus would be overwhelmed, and the conclusion is clear. ARM8 is powerful, but risky for the tasks, whereas ARM7 is stable, power efficient, has no bottlenecks. So if you want to go for a best more workload and workload taking kind of a processor, then we can go for ARM8. If we want to go for something for the IoT devices, which is a trending topic current market, so we can go with ARM7. So it's based on our choice. Thank you.